Welcome back to Free Science Lessons with Salam. By the end of the video, you should be able to know some factors that affect the rate of reaction. You should also be able to describe how to carry out an experiment and follow the rate of reaction when calcium carbonate is added to an acid. But first, let's look at some keywords before we start. Firstly, we have reaction rate. Reaction rate is the speed at which a chemical reaction takes place, measured in increase or decrease of concentration per unit time. Secondly, we have collision theory. It's the idea that for a reaction to take place, the reactants must collide with each other with sufficient kinetic energy and the correct orientation. You can see this in the diagram below. Thirdly, we have activation energy. It's the minimum amount of energy required for a reaction to take place. It's usually measured in energy unit per mole, for example kilojoule per mole. And lastly, we have a catalyst, a substance that will increase the reaction rate but not be used up in the reaction. Catalysts also decrease the activation energy, like shown in the diagram below. Now let's move on to some factors that will affect reaction rate. I have listed some below, like temperature and pressure. Let's firstly start with temperature. As we increase the temperature, the reactant particles gain more energy and move more. This results in more successful collisions, which increases the reaction rate. When we decrease the temperature, the opposite happens, and the reaction rate decreases. You can see in the diagram below, if you increase the temperature, more energy, and if you decrease the temperature, less energy, shown by the arrows. Secondly, we have the effect of concentration on rate of reaction. As we increase the concentration of reactants, more particles can collide with each other and increase reaction rate. This is because the more reactants we have, the more likely collisions to take place. If we decrease the reactants, then there will be less particles, which means less collisions and in turn lower the reaction rate. You can see by these two diagrams here how concentration affects reaction rate. Thirdly, we have surface area. If the surface area of reactant is increased, more particles are exposed to the other reactants, which means there's a greater chance that a collision will happen, which leads to more successful collisions and an increased reaction rate. The opposite happens when the surface area of reactant is decreased. The diagram below shows this very well. Now we have the effect of inhibitors or catalysts on rate of reaction. The addition of a catalyst, as we mentioned earlier, increases the reaction rate, but does not get used up in the reaction itself. It also provides an alternative reaction pathway that requires a lower activation energy. We also have inhibitors, which can also affect reaction rate. They slow down or stop the reaction, which means that they stop the reactants from reacting together. Lastly, we have the effect of temperature on rate of reaction. If we increase the temperature of a gaseous reactant, there will be more reactant particles per given volume, which means there will be more collisions, so the reaction rate is increased. The diagram below shows this very well. As we have seen, all these factors relate to collision theory. The more collisions, the more likely the collisions, the higher the reaction rate will be. Now let's move on to calcium carbonate when added to an acid. Here you can see a balanced equation of calcium carbonate. We can also see that one of the products is CO2, which is a gas. Using this information, we can measure how much CO2 is produced in a set amount of time, using a gas syringe, like shown in the diagram below. This will also allow us to work out the reaction rate by dividing the amount of product by time. If 12 centimeters cubed of gas were produced in 4 minutes, the following calculation would give us a reaction rate. 12, that's the amount of product, divided by 4, which is the time, that would give us 3 centimeters cubed per minute. Don't forget when doing these calculations to include the units. Thank you for watching the video and I hope this helped.